Hello and welcome to part 7 of skimage tutorial, and let's continue our journey to explore more functions in skimage. The first function in this part that we want to explore is label function in skimage. Pretty versatile function. What uh, it identifies a region where the pixels are interconnected with each other within the image and assigns a certain label to that region where the pixels are interconnected with each other. So let's use the function label. And one thing I want to bring to your notice is where do you get the label from. So label is received from skimage.morphology. We import label from skimage.morphology. So let's go to the section of code where label is used. So let's go ahead and run this first line of code on line 89. And the argument we are feeding to label is the BW image. BW image is a black and white image that we created by running adaptive threshold on the original image. Now let's play with this label image a bit and try to understand what this label image is. So let's print straight away label image. What does it look like? All right, so it looks like it's got all the pixel values in it. So let's do a label image dot shape. Okay, so it's got these dimensions 100 and 334. It's basically the same image that we have uh, that we received after creating a section of the original image. So we fed the black and white transformation of that section of the original image to label, and in the label image again we have received the similar image, but what we want to see is what does this really contain, what does the image really look like. Now let's go ahead and do an im show on axis 5 on the plot that we created using many other functions in the previous parts. So let's execute these lines from 91 to 93 and try to see what's got plotted here. So labeled items, there's no change. All right. But we're going to make use of this label image that we got after running the label function on the black and white image. We are going to use the label image in the subsequent function. However, I see one mistake that I have made, which I'd like to correct here. Let me, instead of printing image, let's try to print the label image. And I want to run this again. Let's see. All right, so what you see here is within the black and white image, when you look at labeled items, it has given slightly different shades to each of those coins, which are essentially interconnected set of pixels. And that's how you recognize there's a coin in the image, because it's formed with interconnected set of pixels. And you can see labeling has given slightly different shades to each of the coins. Now let's play a little bit more with this. What if we had to feed image as argument to label? And let's try to run this once again. Oh, things vanish from there. Let's try to print this image once again. Just want trying to do some troubleshooting and really bottom out the confusion which is here. Okay, so basically what comes out is that to the label it's better to feed black and white image rather than feeding a non-black and white image, which can confuse the function and then give you erratic results. this is what happened with us, and try to print this thing once again. Okay, so back to the same earlier picture that we had got by feeding a black and white image to the label function. And what that provided essentially is a modified image where all the interconnected labels forming each of the coins are shaded in a slightly different color of gray. So let's now use the label image for something doing more interesting. We want to create a rectangle around each of the coins. And how do we do that? So for doing that, we use a function called region props. Where does region props come from? Let's go back. So we import region props from skimage.measure. So once you've got image props, then using image props, we are going to create a nice rectangle around each of the coins, which independently, and each of the coin now is a label within the image. So now let's go ahead and run this for loop, which will essentially identify regions within the region props, and we expect those regions to be each of the coins within the image. And around the region, we want to print a boundary box. The B box stands for boundary box. So if you just want to reconfirm that B box stands for boundary box, so let me do a region props question mark, which will give me some information on region props. And just want to confirm B box stands for bounding box rather than a boundary box. It stands for bounding box. So we want to create a boundary box, or rather bounding box, around each of the coins which are there in the image. So let's go ahead and run these lines of code, and I'll explain a little bit more on about these lines once we can see what is the outcome after running these lines of code. So I do an F9, and let's go here. All right, so this is fantastic. So for every region within the labeled image, we have created a small rectangle. It has actually tapped not only the big coins which form a region within the labeled image, but also there are small regions within within the coins themselves which seem to have interconnected pixels. They have been identified as regions within the labeled image, and this function has built a nice rectangle around each of such sets of pixels which are interconnected. So this was an interesting outcome. So the way we did this was, for every region within the region props. So region props would be a list of multiple regions within the labeled image. As I said, a region corresponds to a set of interconnected pixels. For every region, we found a bounding box. Bounding box is defined in terms of minimum row, minimum column, maximum row, maximum column. So minimum row to the maximum row, minimum column to the maximum column. So this way we are able to create a rectangle around the region which exists within the label image. And basically you used mpatches function, mpatches.rectangle, for plotting the rectangle using the coordinates that we received from region.bbox. So min-r, min-c, max-r, max-c are essentially coordinates on the image using which we plot rectangles. All right, so we saw how the regions can be identified, how we can create a bounding box around each of the regions within the labeled image. Now let's go ahead and do something interesting again. All right, so let me run this cell just to get an understanding of what we are going to, what outcome we expect by running these lines of code. So here go